Hey guys, today we're going to talk about if you change the dimensions of a figure, how it's going to affect the area. Okay, so we're going to dive right in. It says on example number 1, describe the effect of the change on the area of the given figure if the height of the triangle is multiplied by 6. Okay, so first we have to find the area of the given triangle. And remember, your area for a triangle is always area equals 1/2 base times height. And since we see that there is a 12 for your base and a 5 for your height, we can just plug those in. That would give you area equals 1/2 12 times 5. And if you go ahead and reduce that, 12 times 5 is 60, and 1/2 of 60 is 30. Okay, so your area would be 30 inches squared for that initial triangle. Okay, but it wants to know what the height of the triangle, or the area of the triangle, would be if the height is multiplied by 6. Okay, so if your height is multiplied by 6, your new height would be 5 times 6, or 30. Okay, so we want to go ahead and see how that would affect our area. Okay, so remember we have area equals 1/2 base times height, except this time we have area equals 1/2. Your base is still 12, but your height is now 30. Okay, so if we go ahead and multiply those out, your area would end up being 12 times 30 is 360, and 1/2 of 360 is 180 inches squared. Okay, so the difference in your area, 30 and 180, if you multiply your height by 6, your area is increased by a factor of 6, because 30 times 6 is 180. Okay, so your area, or your height, if it's multiplied by 6, your area is also multiplied by 6. I would write that down. Okay, let's look at example number 2. Okay, number 2. It says, describe the effect of the area of the given figure if diagonal SU of the kite with vertices 2, 2, 4, 0, 2, -2, and -5, 0 is multiplied by 1/3. Okay, so let's go ahead and graph the ordered pairs. We have 2, 2. We have 4, 0. We have 2, -2. And we have, what was the other one? -5, 0. Okay, so here's our kite. Okay, sorry for my bad drawing. Okay, and we're wanting to find the area of that. Okay, remember your area of a kite is 1/2 diagonal 1 times diagonal 2. Okay, so let's go ahead and find the area of what we've been given. Okay, we got to find the diagonals. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 for this diagonal. And we have 4 for our other diagonal. Okay, so let's go ahead and plug that in. Okay, so we're going to have 1/2, 9 times 4, which is 36, and 1/2 of 36 is 18 units. Okay, and it wanted us to find how the area would change if you took SU, or 4, 0 to -5. If you took this one and reduced it by a factor of 1/3. Okay, so if you took, since that was 9, it would now become 3. So instead of 1/2 D1 times D2, you would have 1/2. And your D1 is now, instead of 9, is now 3. And your D2 is still 4. Okay, so 4 times 3 is 12, and 1/2 of 12 is 6. And you'll see, since you reduce that diagonal by a factor of 3, your area was reduced by a factor of 3 from 18 to 6. Okay, example number 3. It says, describe the effect of the change of the area of the given figure. The height of the rectangle is tripled. Okay, so let's go ahead and find the original area. Remember, your area of a rectangle is area equals base times height. Let's plug that in. Area equals 7 times 4, so your area equals 28. And it said it wanted the height of the rectangle to be tripled. Okay, so your height is 4, so it becomes 12. So you have area equals 7 times 12. And 7 times 12, of course, is 84. Okay, so since your height was tripled, your area was also tripled. 28 times 3 is 84. Okay, we got a couple more examples. This time, it says the base and height of a rectangle with base 4 feet and height 5 feet are both doubled. Okay, so let's draw our rectangle. Okay, we know that rectangle has a base of 4 feet and a height of 5 feet. Sorry for the scale. It's awful. Okay, but just go with it. Okay, so your area is 5 times 4. Okay, so it's 20. And then it wants us to double our height and our base. Okay, so your new shape, okay, we would have 10 for the height, 8 for the base, and that would then become 8 times 10, which is 80. Okay, so since you doubled both sides, it ends up quadrupling your actual area. Okay, example number 5. Okay, let's take a look at this one. It says, describe the effect of the change on the circumference and the area of the given figure. The radius of J is multiplied by 1/5. Okay, so remember, to find the area of a circle, you just have to take pi r squared. Okay, so your area equals pi, and your radius is 10, and square it. Okay, so let's go ahead and do that out. You have 10 squared, which is 100, so your area ends up being 100 pi. Okay, so you could obviously reduce that, but we're not going to worry about it. Okay, and your circumference of that circle, remember, it's your circumference is 2 pi r. Okay, so we're going to put 2 pi in our radius, which is 10. Okay, and if you multiply all that out, 2 times 10 is 20, so your circumference would be 20 pi. Okay, so if we multiplied all of our dimensions by 1/5, all of a sudden our radius would now be 2. Okay, so we're going to do the same calculations except have a radius of 2. Okay, so your area would be pi times 2 squared. And 2 squared is 4, so you have a area of 4 pi. And then your circumference, once again, is 2 pi times your radius. And 2 times 2 is 4, so again you would have 4 pi as your circumference. All right. Okay, so effects of changing dimensions proportionally. If you have a change in dimensions, all dimensions will be multiplied by A. Your perimeter or circumference changes by a factor of A. Changes by a factor of A. And your area changes by a factor of A squared. Okay, so make sure you know those. And example number 6, I will take this as part of the grade. So please try number 6 by yourself and then go ahead and get started on your homework. Have a good one.